Hello everybody. Today, for me anyways, is Saturday. Don't know when you guys are watching this. And today we're gonna look at how to solve equations with radicals. And so one of the main things you need to remember every time we kind of learn a new skill about a new type of function, we have a solve section towards the end of the chapter. The thing that will differentiate solve from simplify is that once again you'll see that equal sign in the question and the instructions will say to solve. So you kind of have two clues there that it's not a simplification. You're trying to come up with x equals a number and have an actual answer rather than just some type of expression. So let's start with something. I outlined some of these in the notes that are also on the announcements for Canvas. But let's look at just something that looks like that. Our step one is always going to be to isolate the radical, which is a fancy way to say get the radical by itself. Whatever's underneath that radical expression, get it by itself, which means that 1 is the extra term in our equation. So we need to move that guy to the other side. So we end up with the square root of x equaling 4. And now what we need to do is you're always going to take both sides of your equation to whatever power would undo that radical. So since this is the square root, the inverse, often called the opposite, but the actual mathematical term is inverse, the inverse operation to a square root would be to square both sides. And when we square a radical, it cancels each other out. And so we have x equaling 4 squared is 16. These are problems that you often want to check. So you want to kind of plug back in. We will look at examples today where some of the questions, some of the answers have to be thrown out. The solutions won't work. And so you do want to kind of just plug that in. You don't have to show all your work on every question, but you do want to kind of at least go through it mentally and make sure it works. So the square root of 16 is 4. 4 minus 1 is 3. And so 3 equals 3, and that checks. I gave you some, I did write it all out when I did the notes. And so you can see those checks and how I wrote them out. All right, let's make it a little bit more complicated. What happens if we have an entire expression underneath that radical, something with more than one term? All right, since that radical extends all the way under that -3, then we're ready to square because this is by itself. And so because it is the square root, we are going to square both sides. That's going to cancel that out. We have 7x minus 3 equaling 25. And notice right here by step 2, there's no more radical. So just solve as normal. Add the 3. 7x equals 28. Divide by 7. Divide by 7. And x equals 4. Come back up here and kind of check our work. And so if x is 4, 4 times 7 is 28, take away 3 is 25, the square root of 25 is 5, and so 5 equals 5, and we're done. Example number 3. What happens if it's not a square root? So what happens if it's a cube root? So let's say we have the cube root of x minus 2 equals 3. The rules stayed the same. We want to make sure that radical expression is isolated or by itself on one side of the equal sign. Doesn't matter if it's the left or the right. And now, instead of taking the square of both sides, we're going to do the opposite or the inverse of this. We're going to cube each side of our equation. So I'm going to take this to the 3rd power. I'm going to take that to the 3rd power. And right here, that's going to cancel that out. And 3 to the 3rd power is 27. Solve as normal. And x is 29. if your root is, and I wrote this out in the notes, if your root is odd, if your index is odd, there's no need to check your answer because every answer will work out fine. All right, it's only if this is the square root, maybe a fourth root, but I'm not going to put any of those on the test. Mostly you'll see square roots here. All right, the square root ones you need to check, and eventually I'll come up with an example. I'm sure I wrote some down here where we'll see a solution that has to be thrown out. All right, don't freak out if there's a number in front of the example, or the example, in front of the radical. Something like that. So now we're going to have 2 steps to get the square root by itself. I would add the 12. We're going to have 3 radical x equals 21. In order to get the radical by itself, I need to undo that multiply, so we're going to divide by 3. And so now I have the square root of x equaling 7. And so I'm going to square both sides to undo that radical. That just scribbles right out. And x is 49. Let's go back and check it, make sure that answer works. This time I'll kind of use this space maybe right here. So 3 times the square root of 49 minus 12. The square root of 49 is 7. 3 times 7 is 21. Take away 12 is 9. That's what it should be. So this answer checks as well. All right. Let's look at one that doesn't. Let's have the square root of x plus 2 plus 3 equaling minus 7. All right, so again, we're going to get the square root by itself. So subtract 3, subtract 3. We have radical x plus 2 equaling negative 10. We're going to square both sides. That's going to cancel that out. Negative 10 times negative 10 is a positive 100. Solve for x. And x is 98. If we plug 98 right here, I didn't leave myself any space to kind of show you the check. So watch what happens. If we plug 98 right here, 98 plus 2 is 100. The square root of 100 is 10. 10 plus 3 is 13. 13 is not the same thing as negative 7. So we throw this answer out. We call it an extraneous solution, similar to like the ones that we did in chapter 6 with the fractions. When the fractions turned out to be 0 in the bottom. All right, this does not give us a solution, so what do we put as an answer? We don't put 0, we would put empty set. Sometimes it's possible to have more than one answer. And there are some in this section that get really, really complicated. And lucky for you, it's one of the hardest questions we do all semester, actually. And those are the ones I'm going to skip because it's just too hard to do remotely and we just don't have time to dive into that level of complexity with the time we have left. And so that's good news for you. All right, so now you see the radicals on the right. I would probably move this 3 over. So the goal is the same. Yes, we have this extra x, and I will deal with that in a second. But let's move that 3 to the left, and we're going to get that radical by itself, even though it's on the right-hand side. So we have x minus 3 equaling the square root of x minus 1. All right, we have the radical alone, so our steps say square both sides. So we're going to square here. The thing that makes this different is that you're going to want to FOIL it. X minus 3 times x minus 3. So we're going to get x squared minus 3x minus 3x plus 9 equals, when I square this piece, it breaks that out, x minus 1. So once again, those factor skills that I said never go away, here they are. This is the only section it really comes up in chapter 10. So let's take this to the other side. Well, let's simplify first. X squared minus 6x plus 9 equals x minus 1. Let's bring this x to the other side. Let's add 1. Hoping I'm still in screen. X squared minus 7x plus 10 equals 0. Let's factor. We have x minus 2 and we have x minus 5. And so my answers are positive 2 and positive 5. I need to check both. And as you can see, I'm running out of chalkboard space. So I want to leave that original equation because that's what I'm going to substitute back. Remember, my answers are 2 and 5. And I'm going to erase everything here. So if I check x equals 2, I'm going to plug 2 in right here. 2 equals the square root of 2 minus 1 plus 3. 2 minus 1 is 1. The square root of 1 is 1. If I bring that down, 2 does not equal 4. So I throw that answer out because it does not check. Over here, x equals 5. Let's plug that in. 5 equals the square root of 5 minus 1 plus 3. So 5 equals the square root of 4 plus 3. So 5 equals the square root of 4 is 2 plus 3. This one is going to check because 5 is equal to 5. So my only solution is x equals 5. Sometimes both are thrown out, sometimes one is thrown out, sometimes neither one is thrown out. So there's no real pattern to that. You have to go back and check every problem. All right, I'm going to give you one more. I would kind of pause the video. Well, you can pause the video anytime you want, clearly. There's not a ton of these that are in the book. And I do think this is an important skill because it keeps those factoring skills for you up. So you might want to try this one. And just kind of try that on your own and then watch me go through it because like I said, there's not a ton of opportunities and we're not doing the more difficult ones that would incorporate the factoring into the problem solving process. So I definitely would try this. All right, so we already have our radical isolated, so we jumped straight to squaring. So that cancels. Over here we have x minus 7 times x minus 7. So that becomes x squared minus 7x minus 7x plus 49. Let's gather my like terms before I move those other terms over. This time I'm going to move them to the right. So I'm going to subtract the x. I'm going to add the 5. And I'm going to have x squared minus 15x plus 54. So my factors are going to be x minus 9 and x minus 6. And so my answers will be 9 and 6. If you haven't checked them, maybe pause again and go back in and check. I'm not going to show you all the work on this one. Let's go back to my original equation. And if I plug in 9, 9 minus 5 is 4. The square root of 4 is 2. If I plug in 9 right there, 9 minus 7 is 2. So 9 checks out fine. And if I plug in 6, 6 minus 5 is 1. Radical 1 is 1. If I plug in 6 here, 6 take away 7 is negative 1. Positive 1 is not the same as negative 1. So that answer I'm throwing out. And my final answer is x equals 9. I actually have one more. I missed it at first. I have one more on my paper, so you can try one more factor one. No harm in going through one more example. It is the square roots of 3x minus 3 minus 1 equals x. All right, so this time we do have, pause it here, try it on your own. And so this time we do need to jump that to the other side before we square. So square both sides. I'm going to save myself this space and just write that twice. That's going to break free. X squared plus x plus 1 becomes x squared plus 2x plus 1. Let's jump these to the other side. Again, I'm going to move everything to the right. So x squared minus x plus 4. I'm missing something here. All right, this is my very last example, and it's the first time I did a typo. So I'm gonna let this video kind of ride, bear with me. I will work it out again. I must have done something, but I've already 8 problems into this successfully. So I'm gonna make section 10.8 later today, and I will rework this one at the beginning of that. So, and I'll have to double check that I copied it out of the book correctly. So thanks for bearing with me. Have a great day, you guys.